Radiant energy. The kinds of energy are very few, although the methods of using, applying, and manifesting same are innumerable. Let us begin with one of the best known forms of energy, namely Heat. Heat was formerly regarded as a very fine fluid or substance called caloric, which was supposed to enter into Substance and then manifest the phenomenon of Heat. This idea has long been relegated to the scrap pile of Science. The present theory, which is supported by a mass of evidence obtained through investigation and experimentation, is that Heat is a form of energy arising from the vibratory motions of the particles of Substance, a mode of motion. The degrees of Heat are termed temperature. Temperature depends upon the rate of the heat vibrations of the particles of Substance, either arising from the original motion of the particles, or else from vibrations or motion aroused in them by transmission from particles of other bodies of Substance, these vibrations being contagious. Temperature then means the measure of the vibrations of the particles. All bodies of Substance have some degree of temperature, some degree of heat vibration of its particles. Science has a pleasant scientific friction of an absolute zero at the degree of 491 below zero, Fahrenheit. But this is merely an imaginary something with which the grown-up children of Science amuse themselves. When two bodies are brought near each other, the nearness being comparative, and in some cases meaning a distance of millions of miles, heat is transmitted from the warmer to the cooler body, until the temperatures are equalized. That is until the two bodies vibrate in unison. In physics we are taught that the transmission of heat may be accomplished in three ways, although the writer is of the opinion that the three ways are but three forms of one way. The first form is called conduction, whereby the vibration or heat is conveyed along a body of Substance, from its warmer to its cooler parts, for instance, an iron poker with one end in the fire. The second form is called convection, whereby the visible motion of heated Substance moving along the air, for instance, hot air, hot water, steam, etc., either by means of pipes or by allowing them to pass freely through the air. The third form is called radiation, whereby the vibrations are believed to be transformed into waves of the Ether, which will be spoken of later, in addition to what has been said on the subject in our chapter entitled "The Paradox of Science." The writer thinks that a little consideration will show us that the same rule operates in all of the above cases, and that conduction and convection are but forms of radiation. For instance, in conduction there must be a few particles first set into vibration, the same gradually passing on to the others farther and farther away. Passing how? By contact, replies physics. But the particles are never in absolute contact. There always is plenty of space between them, and so there must be some kind of waves passing through the space between them, which space is not filled with air or other form of Substance, but only with the Ether or something that takes its place. So that, after all, conduction is but a form of radiation, and the same rule will apply in the case of convection. Heat arises from several causes, all of which, however, manifest through the vibration of the particles of the body evidencing the heat. These causes may be stated as 1. Original motion of the particles of a body of Substance, arising from some workings of the Law of Attraction, and including motion arising from chemical action, combustion, etc. 2. From transmission or contagion from some other body of Substance, the particles of which are vibrating at the rate of heat. 3. From interrupted motion, including friction, both of the moving body with the air or other substance, and the friction of a current or electricity passing through the body. In each of the above cases, the actual and immediate cause of the heat is the vibration of the particles of the Substance manifesting the heat, although the transmitted vibratory waves, or the interrupted motion, friction, current, etc., may have been the instigator or provoker of such vibration. The interrupted motion, friction, or wave does not produce the heat, but merely arouses or provokes the increased vibration of the particles that really manifest the heat. At the least, remember The heat is in the particles of the body that feels or experiences it. The vibrations of heat seem to have the properties of causing the molecules to draw further apart, and to manifest less attraction or more repulsion, whichever way one cares to express it. This moving away of the molecules tends to cause the body to increase in volume or size, and occasions what is known as "expansion" in Substance. In this way heat transforms solids into liquids, liquids into gases or vapors, the change being wholly a matter of the relative distances of the molecules. Magnetism is another form of energy, and is generally believed to be a part of the phenomena of electricity, if indeed not a form of electricity itself. Science knows very little about the nature of magnetism, but in a general way holds to the theory that it results from the vibration or motion of the particles of Substance, as do all other forms of energy. The magnetic qualities of a body may be increased or decreased by motion affecting the relation of the molecules, which fact has been regarded as having some bearing on the theory. Electricity is a form of energy that Science regards as also arising from the vibration or motion of the particles of Substance. It is transmitted like heat, by conduction and radiation, the waves tending to provoke similar vibrations in the particles of substances receiving them. By many careful investigators, electricity is believed to be very closely related to the phenomenon called light, both having much in common. Science seems to be discovering new points of resemblance between them, and it is possible that in the near future they will be seen to be but varying forms of the same thing. The purposes of this book do not call for an extended consideration of the properties of electricity, the same being served by a consideration of its nature being akin to that of the other forms of energy, namely, vibration or motion in or among the particles of matter. Light is a form of energy, the study of which is of the greatest interest to Science, for the reason that the field seems to be widening out continuously, and reaching out into the territory formerly thought to be the special region of electricity. And in another direction, it seems to be reaching out into the territory of heat, the latter being considered by many to be but a form of light, in its lower vibrations. In fact, the writer of this book so considers the subject, and for the purposes of this book, in latter chapters he will combine electricity, heat, and light, including also the phenomena known as the X-rays, Becquerel rays, radium waves, etc., as forms of light, the combined forms of energy to be called radiant energy. In this combination he believes that he is in line with the latest and best thought of modern science. However, he does not insist upon his readers following this idea, and so, if they prefer, they may think of each of these forms as separate and distinct, and yet not run contrary to the line of thought of the book. Light is not the simple thing that it is considered to be by the general public. It is composed of many parts, qualities, and manifestations. Its rays, when separated by the spectrum, are seen to consist of waves or vibrations of differing degrees of rate and intensity. The lower range contains the heat rays, and it is interesting to know that there are rays of heat too far down in the scale to be evidenced by human senses that may be distinguished by delicate instruments. But there are rays still further down in the scale that are known to exist, theoretically, that cannot be registered even by the finest instruments. To gain an idea of the delicacy of these instruments, let us remember that Professor Langley has an instrument called the bolometer, that is so delicate that it registers a change of temperature of 1/1000th of a degree, and will register the heat of a candle 1 1/2 miles distance from it. Light vibrations arise from combustion, friction, electricity, etc., causing the particles to assume increased motion. Let us consider the report of the spectrum. Beginning with waves or vibrations far below the sensibility of man, the scale shows an advance until the first "warm" vibration of iron was reached. This first indication of warmth comes when the vibrations reach the rate of 35 trillion per second. Then gradually they increase until a dull red glow is noticed, the lowest visible light ray, when the vibrations are 450 trillion per second. Then come the orange rays, then the golden yellow, then the pure yellow, then the greenish yellow, then the pure green, then the greenish blue, then the ocean blue, then the cyanic blue, then the indigo, then the violet, the latter evidencing when the vibrations reach the rate of 750 trillion per second. Then come the ultraviolet rays, invisible to human sight, but evidenced by chemical media. In this ultraviolet region lies the X-rays, etc., and also the actinic rays that produce photographs, sunburn one's face and blister the nose, that cause violent explosions in chemicals that transform forms of substance, that are employed to cure skin diseases, etc. These actinic or chemical rays have an important role to play in plant life, for they act upon the green leaves of the plant, causing a chemical change by which carbonic acid and water are transformed into sugar and starches. Some of the rays of the ultraviolet region of light penetrate substances formerly considered solid and impenetrable, and some of them, emitted from radium, etc., would destroy organic life if applied in sufficient quantities. Some of them are practically waves of electricity, so that light and electricity are seen to be closely related. To give one an idea of the differences produced by different rates of vibration, let us imagine a mass of iron, shaped like a great top, capable of being impelled to spin, at a constantly increasing rate of speed, by some mighty will. At first it is seen as a slowly spinning top, manifesting nothing but slow motion to our senses. Now imagine our top spinning at a rate doubling each second. The first second the top spins at the rate of 2 revolutions per second. We notice no change except that we can see the movement. The next second the revolutions are doubled to 4 per second. Then, doubling each second, we have, respectively, revolutions of 8 per second, then 16, and then in the 5th second 32 per second. Then we begin to notice a change. When the revolutions reach 32 per second, the friction of the moving top on the air causes it to give forth a very low, deep bass note of sound. This note is like a low, deep hum, and is the lowest possible of perception by the human hearing, although it is possible that some of the lower forms of life may be conscious of still lower vibrations. The 6th second the revolutions reach 64, and the low note has grown much higher in the scale. The 7th second records a rate of 128, and the note has correspondingly increased. Then, as the seconds pass, we have successively 256, 512, 1024, 2048, 4096, 8192, 16,384, 32,768, the latter in the 15th second, and representing the highest note recognizable by the human ear, although it is believed that some of the lower animals may recognize sounds too acute for our sense of hearing. During this increase in revolutions from the 5th second to the 15th, the sound note has risen rapidly in the scale from the low sullen hum on through the notes of the musical scale and beyond the range of instruments, until the shrillness becomes so intense as to be almost unbearable, and finally terminating in a shrill, piercing shriek like the squeak of the bat, only long drawn out. Then, from the termination of the sound, by reason of the rate of vibration having become too high, silence reigns for 30 seconds. Absolute silence, in spite of the rapidly increasing rate of vibrations, in fact, because of it. When the 45th second is reached, and the revolutions have reached the rate of 35,184,372,088,832 per second, our top begins to emit heat rays increasing each second. Then a little later a dull, dim glow may be noticed. Then, as the seconds fly, the dull glow manifests a deep dark red color, such as one notices in the iron of the blacksmith's shop soon after it begins to glow. Then, on and on, as the seconds fly, the deep red grows lighter and brighter, gradually changing into orange, then into yellow, then into green, then into blue, then into indigo, then into violet, and then into the color of white heat. Then this white heat changes into a still more dazzling white, and then a white impossible to describe appears, so bright, clear and brilliant that the eye cannot bear the sight. Then suddenly the intense brightness is succeeded by absolute darkness, and the moving top cannot be seen by the eye, and yet it moves on. The highest recorded chemical rays of light are estimated to equal a rate of vibration of 1,875,000,000,000,000 per second. The vibration of the lowest shade of red light is estimated at 450 trillion, and the highest of violet at 750 trillion per second. So we may imagine what the highest line on the spectrum is like. Still vibrating, our top, which has become now a mass of vaporized iron, rapidly tending toward still more ethereal forms, it has passed out from the region of light waves into another unknown region of vibrations, in which region, however, exist the vibrations known to us as the X-rays, etc. It is throwing off great quantities of electrons. If we were to use a fluorescent screen, we would be able to observe the phenomena of the Röntgen rays, and similar manifestations of radiant energy. On and on vibrates the top of what we once called iron, cold iron, warm iron, hot iron, melted iron, gaseous iron, etherealized iron, if you like. What it is like now, the imagination of man cannot conceive. Still the revolutions continue, doubling each second. What is being produced? The imagination cannot conceive of what this state of substance, now being reached, is like. By a scientific form of poetry we might think of it as melting into energy, pure energy, if there were such a thing. Long since it has been resolved into its original particles, its corpuscles, and perhaps into the stuff from which particles are made. But we must let the curtain drop. The wildest fancy cannot follow the dance of Substance any further. The theory of the transmission of vibrations of radiant energy by means of waves in the Ether, or something that takes the place of the Ether, has been mentioned in other parts of the book. Referring again to it, the writer would say that he thinks it probable that the waves, coming in contact with the countless corpuscles in the Earth's atmosphere, communicate a high rate of motion to them, the result being that they take on the vibrations immediately, and pass along with the wave current. The result being that much that we consider as waves of light, heat, and electricity are but streams of these corpuscles in which vibrations have been awakened by the waves. This idea will help to explain some of the phenomena of light which seemed more understandable under the old light corpuscle theory of Newton than under the wave theory of recent years. The idea is advanced merely for the purpose of setting down the thought, for it plays no important part in the theory of the book. Another matter that should not be overlooked in connection with light and heat and electricity is that particles absorb or catch the vibrations in different degrees, their receptivity depending upon their particular vibratory mode or custom of their kind. If unable to absorb the vibrations, they reflect them. Substance of any particular kind absorb heat in the degree of its atomic weight. In the next chapter we shall learn something of the Law of Attraction, that wonderful law that makes possible any motion or radiant energy.